Okay, another example, 7.2 from your textbook. Here, what do we have? We have a salesperson who wants to make calls to try to sell the people whom he's calling. Now, based on past experience, he knows that there's 20% chance that once he calls a person, he can close a sale, meaning that he will make a sale. The person will accept to buy whatever the salesperson is selling. We need to find the probability distribution of the number of sales that he makes once he make 3 calls, right? Because here the question is he wants to make 3 calls. He's going to call 3 people, and he's wondering how many sales he's going to make, and that's the question. And so in fact we're trying to find a probability distribution for X, where X is defined as being the number of sales made after 3 calls. Okay, so how to do this? The best way to do or to find these probabilities is to draw a probability tree. So let's do that step by step. So he will make the first call, right? After making the call, there are 2 possible options only, correct? It's either he will make the sale or he will not make the sale. So I'm calling that S for sale and N for no sale. Then he will make a second call, right? So if he make a sale at the beginning or from the first call, then he makes a second call, and there are also chances that he will make a sale or no sale. And the same also, if after the first call he did not make a sale, still when he makes the second call, there are only 2 different possibilities, right? And for the third call also, that can originate from either this event or that event or this event or that event. We always have only 2 possibilities. So which means at the very end I can have 8 final possibilities. Before listing these possibilities, let's first put the probabilities on the branches. Remember, on a probability tree, it's very important that we put the branches. Put the probabilities on the branches. So, what the probability that we have a sale? All right. What do you think? This is given to us. It's 20%. So that's it. We simply here write 0.2. So what about the probability here? What is it? Okay. That's very easy, because this event is the complement of the other event. We have only 2 events, which means the probability here will be equal to 1 minus 0.2. So that's 0.8. And the same probabilities are on the branches at the different trials, right? Or the different calls. Why? Because we were not told about the effects that in the second call he will increase or decrease the chances that he will make a call. Nothing was told to us. So we assume that no matter how many calls, it's always that the probability of a sale is 20%, which means the probability of no sale is 80%. So let's put these here and there and on all the branches. So we're almost done, but before we find the final probabilities, let's first list the outcomes. The outcome of our experiments. Remember, the experiment is to make 3 calls. So I need to see what are the possible outcomes. What we have to do, we learned that in class, how to list the possible outcome. All what I have to do is to read the outcome on every step of the tree. So let's start from here. We make a call, then we have a sale, then we move here, we have a sale, and then we move here, we have a sale. So we call that sale, sale, sale. Second one, we have a sale, then we can go now this pass again sale, but now instead of moving here we move down and we have a no sale, so we call that sale, sale, no sale. Now the third one, now you should be familiar with that, it's sale, no sale, sale, then sale, no sale, no sale, then NSS, NSN, NNS, and NNN. These are all our possible outcomes. Why this is important? Because now I know if I have a probability associated with every outcome, I know that the sum of the probabilities should be equal to 1, and this is very important. And the question is, how can I find the probability here? So I can call that P of X. If I denote X as being the number of sales made after making 3 calls, this is my X. So what's the probability? Also, we learned that in previous segment that to find the probability of an outcome of a probability tree, what we have to do is we multiply the probabilities on the branches that lead to that specific outcome. And this outcome comes from these. So we have 0.2, 0.2, and 0.2. So I multiply these probabilities and I get the probability that we have 3 sales. Now to get the second one, probability of 2 sales and then no sale, it's 0.2 again, 0.2, and 0.8. So I multiply these. And I do the same for the remaining outcomes. I'm sure that now you know how to do that. Alright, so we're almost there, but remember the question was find the probability distribution. And probability distribution means I need to have a table like that, where I have X in the first column showing all the possible values of X, and on the second column I need to find the probability. Now, about X, how did I get these? I know that when I make 3 calls, I will either have no sale at all, I can have 1 sale, 2 sale, or 3 sales, right? This comes from the logic of the situation that we have on hand. Now, what the probability that we have 0 sales? All what I have to do now is I go to the final column here and I see which case satisfy 0 sales. 0 sales is only here. Here we go, where I have no, no, no. So what I do here, I know that this probability will be equal to 0.512. Now, what's the probability that I have 1 sale? 1 sale means that this one is 3 sales, so it does not satisfy my condition. This one is 2 sales. This one is 1 sale, so this is 1. Then this one also satisfies my condition, and this one. So what do we do? Remember one of the rule of the probabilities that we sum up their probabilities. So it's 0.128 plus 0.128 plus 0.128, and we get 0.384. Now the probability that we have 2 sales. So I have this situation, I have 2 sales, and here I have 2 sales, and here I have 2 sales. So what I do, I sum up also the probabilities of these events. 0.032 plus 0.032 plus 0.032, and we get 0.096. And finally, what's the probability that we can make 3 sales? In fact, there's only one outcome that satisfies this condition, and here we go. So all what we do here is to read that probability, which is 0.008, and we write it down here. And that's it. This is what we call a probability distribution, where we have all the possible values of X and all their associated probabilities.